Now, let's talk a little bit about how the shapes would be drawn. As we said, we would like to cater to different technologies. Let's assume that we would like our shapes to be drawn or displayed using the Swing technology or the Java FX technology or the ART technology. And we know that the drawing technology will change over time. So this is our plan, or at least one plan. We have different types of shapes like line, label, polygon. We could add to this circle, rectangle, so on and so forth. And it is convenient to have a single collection that would store all the different types of shapes. So we have a superclass called shape, which these three inherit from. Now, how do we render a shape like a line or a polygon? Let's take a polygon because that is a little more interesting than a line. Who should bear the responsibility for drawing a polygon? There are two aspects. One is that there is a technology involved here. So the rendering would depend on the technology. You know that if you use JavaFX, the kind of methods that you need to call, the kind of packages that you need to use, they are all dependent on that technology. It is different from what you use when you use Swing. So there is a case to be made that the responsibility for drawing a single shape should rest with the physical view, the view that is tailored for that particular technology. But if you look at it from a different angle, the details of a polygon, where are the vertices of the polygon, that information is only available in the polygon object. So there is a case to be made that the polygon should be responsible for rendering itself. So we have a conflict. There are multiple technologies, and there are multiple types of shapes. So where should rendering be done? Suppose we say, since the shape knows where or what its representation is like, let's assume that the shapes determine how to render a render itself. So we could have the line rendering itself, the label rendering itself, the polygon rendering itself. But then it has to be tailored to the technology. So what we could do is we could have one class under line for drawing using the Swing technology, a subclass of line using for drawing line using the FX technology, one subclass of line for rendering it using art, and if there is a fourth technology, one more class for that. Similarly, we could have subclasses of label for rendering the label using the different technologies. So for every shape, we will have X number of subclasses, one for each of the X technologies. This is a large number of classes. So number of classes would be number of types of items times number of different types of user interface packages. We would like to reduce this to a much smaller number And that is done through what is called the bridge pattern. It reduces the large number of classes that you would otherwise have had into a much smaller number. And that is done like this. We have a hierarchy of shapes as before. So we take the top part of this, the first two levels of this, we keep that. So there is a shape superclass, a line, label, polygon, circle, rectangle, etc., etc. All the shapes come under this superclass shape. They are all subclasses. And every shape is responsible for rendering itself. So there is a render method. And you can see that a render method has a parameter that says renderer of type renderer capital R. What is this for? Well, we are going to have a collection of methods. This is only a subset, just to give you a sense of what it is going to look like, of draw methods and a few other types of methods in an interface, or it could be an abstract class. It doesn't really matter that much, of type renderer. So these are all abstract methods and implemented by once for each technology. So there is one implementation of a renderer for swing, one implementation of a renderer for FX, one for art. And what are these methods? This draw method here takes a string, that is the third parameter, and displays that string at this coordinate. Actually, this should be y, x and y. The x and y coordinates are passed. There is a typo here. And that would be useful for drawing a label. The second method is going to draw a line from the first point given by x1 and y1 to the second point given by x and y. Perhaps they should have been x2, y2. Ignore the typos here. So draw a line from this point to this point. The third method is very different in its nature. This can be used, the set color method can be used to give a color to that shape so that the technology will render the shape in a certain color. So you're passing the amount of red, green, and blue. We could have some understanding that between the shape hierarchy and the renderer hierarchy, that the integers for each of these three would range from, say, 0 through 255. 0 means no value for that particular color component, and 255 means maximum. So how would things work? Let's assume that we are having a polygon to render. So the polygon class would give a concrete implementation of the render method. What it could do is go through every vertex and draw a line from that vertex to the next. So this would be in a loop. The render method for polygon would be in a loop, going through each vertex. And for each line that connects that vertex to the next one, it will call this method of the renderer object. So it would have renderer.draw and pass the x and y coordinates of the two vertices. The line object would simply call this draw method once. The label object would call this first method once. And each of them could call the set color method at the beginning. to set the color. And these would be implemented using the appropriate methods of the 3 different technologies. Art will have its own implementation of the draw methods. FX will have its ways of drawing labels and or text and lines and setting colors and so on. So would be the case for swing. So if you add a new technology, all you need to do is implement these methods in a separate subclass. If you add a new shape, you add that shape over here and then use and implement the render method. So you don't have to create so many different classes as here. Instead, we are simply reducing the number of classes to the sum of the types of shapes and user interface packages. Notice that the kinds of draw methods here should be sufficient to take care of all possible shapes. For example, I don't have a mechanism for drawing images. So if you have image as a shape, then we are going to be in trouble. So when you create the renderer interface or the abstract class, if you want to choose it as make it an abstract class, you should select, you should have enough functionality to take care of all potential shapes.